Hi, and welcome to Great Expectation Tuitions. I'm Mr. Deonaran, and in this video, and in a series of videos, we are going to be looking at some challenging questions in Mathematics Paper 1, Grade 12. In this video, we are going to look at a probability question. So let's get started. Okay, let's look at this question in probability. Now remember, in probability there are different types of questions that we can get. So we must be prepared for the different scenarios. In this question, we are told that a box contains 7 cards numbered 1 to 7. 2 cards are drawn at random without replacement. So that's very important. Find the probability that the numbers on the 2 cards drawn out of the box will give an odd product. So we're looking at drawing 2 cards one after the other, and we want to determine that these 2 cards that we drew will give us an odd product. What's the probability of that? Now the best way to answer this question would be to draw a tree diagram. So if we look at how I'm going to approach it, we're going to start and look at our first draw. Now the first thing we should do is list our card numbers. So we have 1, 2, 3, 4, 5, 6, 7. As you can see, we have 4 odd cards in our box and 3 even cards. So when drawing our cards at random, our chances are we'll either get an odd card or an even outcome. And in our first draw, we could see that the success of getting an odd card would be 4 out of 7. And for an even card, it would be 3 out of 7. Good. So that was our first draw. Now in our second draw, we have our 2 branches again. That's our second draw. But in this draw here, remember, we are not replacing a card. So again, we can either get an even or an odd outcome. Since we do not replace the cards, the number of cards now would be 6. So if we draw an odd card in our first draw, so we will be left with 3 odd cards out of 6 in our second draw. And our even cards would still be 3 out of 6. But let's say we draw an even card. So our even cards will reduce by 1. So we'll have 2 out of 6. But our odd cards will still remain there. So we'll have 4 out of 6. So these probabilities are very important in determining the answer to our question. Now as we can see, to get an odd product, and if we just play around with the numbers, we can look at an odd times an even number, like 1 times 2 is equal to 2, or 2 times 3 is 6, so that product is even. If we look at 2 even numbers multiplied, 2 times 4, we will get 8. And if you look at now drawing an odd and an odd card, for example 1 and 3. So 1 times 3 is 3, or 3 times 5 is 15. So we have an odd and odd outcome, odd and even and odd, or an even, or even. So all of these here will not yield an odd product except for drawing an odd followed by an odd card. So we would say that the probability of getting an odd product is going to be equal to, if you look at our branches, it's 4 out of 7 times 3 out of 6, which is equal to 12. 7 times 6 is 42. If we want to simplify that there, and you can leave it in fraction form, 6 will go there 2 times, 6 will go there 7 times. So there, that is the probability of getting an odd product from this draw here. Okay, so I hope that helped to refresh some of your concepts on the tree diagram, and also looking at drawing without replacement. We will now go on to our second problem in probability. Right, in our second example, we are looking at a Venn diagram example. So we have two events A and B in the sample space S. So our sample space S, we label that our events A and events B. Now it's given that the probability of A is 0.55, the probability of B is 0.6, and the probability of A and B is 0.25. Draw a Venn diagram to represent the information. As you see, we got started here. Now we would start with our intersection, which is 0.25. That's A and B. Now the probability of A, remember, is included when they tell us 0.55, it's including the intersection, which is 0.25. So if you want the probability of just A only, it would be 0.55 minus 0.25, which is 0.3. And for the probability of B, likewise, probability of B only will be 0.6 minus 0.25, which is 0.35. Right, so far so good. We have completed the Venn diagram, but not just yet. As you can see, that our total probability must be equal to 1. So if we calculate the total probability here, it's 0.3 plus 0.25 plus 0.35, that will give us 0.9. So our probability is 1 minus 0.9, which is 0.1, and that sits out there in our sample space. Right, so in our first question, in our second question, we want to determine the P of A and B complement. Now if you look at this question, if you look at probability of A and B complement, so because we've got the intersection here, so we have to exclude all this probability from our answer. So we end up with the B complement being just, change the color, it will be that section there, and that's B complement. So answer for this is 0,3. Okay. Now, if they asked us the probability of A or B complement, now how does that change the answer? So we look at the probability of A or B complement. So now we are looking at the probability of A, which is 0,3, and because it's B complement now, or, so we look at B complement as being just excluding this as being B complement. So we still have 0,25, and don't forget our sample space, that's here, so it's 0,1, and our total probability for that is 0,65. So a bit of a challenge, but we need to look at it, and the Venn diagram, by drawing and looking at the exclusion part, we are able to determine the probabilities of the answer. So I hope you found these questions stimulating, and we will continue with our series of videos on challenging questions in our next video. Bye for now.